right, test tomorrow is on 2.1 through 2.4. Up top it says review all material in sections 2.1 through 2.3 and the 2.1 to 2.3 quiz, as well as the 2.4 practice problem. So that was that classwork that you guys had, and then also make sure you go over the quiz as well to study. So a couple questions. I'm going to do like one of each type of question. So looking at number 1 first, we want to use the remainder theorem to solve. So here it tells us exactly what we're going to put outside the box, -2. Inside the box, we need to make sure we're not missing any terms. I have x to the 4th power, 3rd power, 2nd power, but I'm missing x to the 1st power. So in that spot, I'm going to put a 0x. This was a very common mistake that people made on quiz. So don't forget to put a 0 in that spot. So we have 4, -16, 5, 0, and 9. So we're going to start by dropping down the 4, multiply on the outside. Be careful with the math that you're doing inside. Just be careful with your signs, be careful with your addition. The other common mistake that people would make with this type of question is they messed up a sign and it threw off the whole answer. So -2 times 4 would be -8. -8 plus -16 would be -24 times -2 would be +48. Plus 5 would be +53, times -2 would be -106, plus 0 would be -106, times -2 would be 212, and then plus 9 would be 221. So what would our answer here be? Awesome. The remainder theorem, it's just the remainder that's our answer. So f of -2 equals 221. So 221 is our answer. If you put 4x to the 3rd power minus 24x squared and all of your terms, I took points off on the quiz. When you're using the remainder theorem to solve, it is just the remainder that's your answer. For 4, we want to use the rational root theorem to find all the real roots. So this is last over first. Last over first is our rational root theorem. This gives us our possible options for our factors, our possible zeros. We just have to use synthetic division to test and see what our actual zeros are. But looking at number 4, what do you think I could do first here? Let's take out an x. I'm going to take out an x, and that'll make this x to the 4th power plus 6x to the 3rd power minus 9x squared minus 44x minus 30. So when I take out an x, this is one of my zeros. I would say x equals 0. So x equals 0. Now we only have 4 zeros left to find. So now we can do last over first. So factors of -30, or factors of 30, would be plus or minus what? 1, 32, 15, what else? 3 and 10, 5 and 6, perfect. And then factors of our first would just be plus or minus 1. So inside of our box, we have 1, 6, -9, -44, -30. We're not missing any terms, so we're good there. What do you want to try first? All right, let's try -1. So we're going to drop down the 1, multiply -1, we get 5, multiply -5, add -14, multiply +14, add -30, multiply +30, add, we get 0. Does it work? Yep, so I'm going to add that to my list, -1. So we've got 2 zeros down. That means we have 3 left to find. What can we do next? We want to do it again. But now when we do it again, we're going to use these numbers because we want to keep making our polynomial smaller. So inside the box, I have 1, 5, negative 14, a negative 30. Let's try 3. So we're going to drop down the 1, multiply, we get 3. 8, multiply, this would be 24. Add, we get 10, multiply 30. Add, we get 0. Does it work? Yep, let's add 3 to our list. How many zeros do we have left to find? 2. Once you only have 2 left to find, just factor this. So we have 1x squared plus 8x plus 10. Do we have 2 factors of 10 that add to 8? No. So what do we do if it doesn't factor? Quadratic formula. So our quadratic formula, I'll do it on the side over here so we have more room. We have x squared plus 8x plus 10. Our a would be 1, b is 8, and c is 10. So our quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So negative 8 plus or minus the square root of b squared would be 64 minus 4 times 1 times 10 over 2 times a. So 2 times 1 would just be 2. So negative 8 plus or minus the square root of 64 minus 40 over 2. Negative 8 plus or minus the square root of 24 over 2. Can we simplify the square root of 24? What are 2 factors of 24? 4 and 6. 2 factors of 4 would be 2 and 2, and 2 factors of 6 are 2 and 3. Circle any pairs we have. So this would be negative 8 plus or minus 2 square root 6 over 2. Now let's see, does this simplify? Are all 3 of our whole numbers divisible by the same thing? Yeah, we can divide them all by 2. So we have negative 4 plus or minus. We wouldn't say 1 square root 6, it would just be square root 6. And we wouldn't put it over 1 because that just makes it a whole number. So it'd just be negative 4 plus or minus square root 6. So this is our other 2 answers. So we couldn't have gotten those using our rational root test because they're not rational. They have a square root, they're irrational. So that's why once you get down to the last 2 that you have left to find, you want to factor. And if it doesn't factor, you have to use your quadratic formula. So negative 4 plus or minus the square root of 6. This is 2 answers. We have negative 4 plus the square root of 6 and negative 4 minus the square root of 6. So these are all 5 of our answers. I'm not going to work number 3 out all the way, but I do want to talk about it since our leading coefficient here is not 1. So when we use last over first here, we would do plus or minus factors of our last. So what are factors of 20? 1 and 20, 2 and 10, what else? 4 and 5, awesome. Over factors of our first, so factors of the first here would be what? 1 and 3. So we have all of the whole numbers. We've got 1 over 1, 20 over 1, 2 over 1, 10 over 1, 4 over 1, 5 over 1. But we also have the fractions. We have 1 over 3, 2 over 3, 20 over 3, 2 over 3, 10 over 3, 4 over 3, and 5 over 3. My suggestion would be try all the whole numbers first. Do synthetic division with the whole numbers. Try positive and negative 1, positive and negative 2, positive and negative 4. Break it down, and then at the end, factor, and one of your answers when you factor might be a fraction. So try the whole numbers first. That way you're not doing synthetic division with fractions. Let's do number 5. So a common question that people asked me yesterday with number 5 is, should we distribute the negative first? You can, but just be careful. If I had, let's say, negative 3 times 4, like this. I wouldn't distribute the negative to the 3 and the 4, because then that would just make it positive. It'd only get multiplied to one of the numbers, and then it would just stay negative at the end. So if you distributed, you'd only distribute it to one of the parentheses, and then FOIL with the other one. I would just say multiply the negative at the end. Let's FOIL these two together first. We'll get our answer, and then we'll distribute the negative. So when we FOIL here, what's negative 7i times 6? Negative 42i, perfect. The negative 7i times 10i would be negative 70i squared. 11 times 6 would be plus 66. And then 11 times 10i would be plus 110i. What should we do next? Change the I squared. So I squared is going to become negative 1, which does what to our negative 70? It makes it positive. So this is now positive 70. What should we do next? Combine our like terms. We've got 70 plus 66 be 136. And then negative 42i plus 110i would be what? Awesome, 68i. So plus 68i. Now this is all still kind of in those extra parentheses that I added. We still have to distribute the negative to them. So I just FOILed, but I still have that negative on the outside. So I want to distribute. So we have negative 8 minus 136 minus 68i. Then we just want to combine our real parts together again. So we're going to combine our like terms here. Negative 8 minus 136 would be what? Negative 144 minus 68i. Does it matter the order that we put the terms? Yes. Standard form, the real part goes first. The imaginary part comes second. All right, let's look at 7. 7, when we're dividing, our goal is to get rid of the i's from the denominator. So what would we do here? No, what do?
You multiply by the opposite. It's called the conjugate.
We multiply by the conjugate of the denominator. What would our conjugate of the denominator be?
10i plus 2.
Awesome, 10i plus 2. So the terms stay the same, just the sign in the middle changes. So it doesn't matter if the I goes first or second when you're multiplying. We'll change that at the end. Just the sign in the middle changes. So whatever I multiply to the bottom, I also have to multiply to the top. So 10i plus 2 gets multiplied to the top as well. So we can FOIL out the top first. So up top we are FOILing. We've got negative 8 times 10i would be negative 80i. Negative 8 times 2 would be negative 16. I times 10i would be plus 10i squared. And then I times 2 would be 2i. Let's finish simplifying the top. What should we do next? Awesome. Let's change the I squared to be negative 1. So that would make this negative 10. Then we can combine our like terms. So I'm going to combine the real parts first. Negative 16 minus 10 would be negative 26. And then the imaginary parts, we have negative 80i plus 2i would be negative 78i. So that's the top FOILed out. Now we can do the same thing with the bottom. If you want to FOIL it out, you can. Or you could do your conjugate shortcut. Our conjugate shortcut is a squared minus b squared. So that would be 10i squared minus 2 squared. Again, you can FOIL it out if you want to. I like to do the conjugate shortcut. Saves us a step because the outside and the inside when we FOIL end up canceling. So 10i squared would be 100i squared. Minus 2 squared would be 4. What should we do next? I squared changes to be -1, which makes this -100. So -100 minus 4 would be -104. So -104. Now looking at our answer here, can we simplify? Yeah, what goes into -26, -78, and -104? Yeah, -26 works. So we can divide them all by -26. Perfect. Divide by -26. Divide by -26. And divide by -26. So we get 1 plus 3i over 4. So that would be our answer. I know WebAssign made you separate it. If you want to separate it, that's fine. Or you could leave it together. Either way works. So it'd be 1/4 plus 3i over 4. Either way. You can just leave it as one fraction. Just make sure you simplify your fraction. So for 9, I want to find the vertex and our x-intercepts. What would we do to find the vertex here? Awesome. Our little formula for the vertex is -b over 2a. And then once we find the x in our vertex, or the h, then we plug in to find the y. So we have a, b, and c. So -2 over 2 times 4 would be -2 over 8. Which simplifies to -1/4. So our x value in our vertex, or h, would be -1/4. How do we find the y? Awesome, we're going to plug in the x. We're plugging it into our x values here. So we have 4 times -1/4 squared plus 2 times -1/4 plus 1. So just be careful with the math. A lot of people made mistakes on finding the y value on the quiz. So -1/4 squared would be 1 over 16 times 4. This would simplify to 1/4. Then we have plus 2 times -1/4 would be -2 over 4. And then plus 1, if you want to change it in this step to give it a common denominator too, we could make it 4 over 4. Then we can just add our numerators together. 1 minus 2 would be -1. -1 plus 4 would be 3, so 3/4. So this would be our vertex. -1/4, comma, 3/4. So our axis of symmetry would be x equals -1/4. Domain would be -infinity to +infinity. For range and max and min, it depends on which way our graph opens. So let's just lightly sketch it here. So my vertex is going to go to the left to -1/4 and up 3/4. So it'd be up here. Does my graph open up or down? It opens up. So our range would be from the y value to infinity, since our graph is going to infinity, and it gets a bracket. So 3/4 to infinity. If your graph was going down, it would start with the -infinity and then go to the number, but the number gets a bracket. Our vertex, is it at the maximum or minimum? It's at the minimum value, and our minimum is the y value, so 3/4. It doesn't matter. Just the number is fine, because like y equals kind of makes you think like it's a line, but just give me the y value. And then make sure you answer if it's maximum or minimum. Now let's find the x-intercept. What do we do to find the x-intercept? We make y 0, awesome. So the x-intercept, we plug in 0 for y. So we have 0 equals 4x squared plus 2x plus 1. What would we do next? Awesome. We would want to factor, so multiply the first times the last. 4 times 1 would be 4. Do we have two factors of 4 that add to 2? No, we don't. What do we do if something doesn't factor? Quadratic. But before we do the quadratic, let's look at our graph. Do I have an x-intercept? Does our graph touch the x-axis? No. So just by looking at our graph, we know that we have no x-intercepts, or we could say none. If when you graphed it, you do touch the x-axis, then you'd want to use your quadratic formula, because it is possible that you can have x-intercepts, but they're just not whole numbers. They're going to be, they could be, well, if they're imaginary, they're not touching the x-axis. So here, when we do our quadratic formula, we have -2 plus or minus the square root of 2 squared would be 4, minus 4 times 1 would be minus 16. Yeah, over 2 times a would be 8. So under my radical here, I end up with -12. If we have a negative under our square root, that's imaginary. Your imaginary numbers are not going to be x-intercept. If it was positive, you can have your x-intercepts and it just not be a whole number. That would work. But because it's negative, because it's imaginary, that means we have no x-intercepts. But if you just graphed it, you could tell by graphing it that we're not going to have any x-intercepts. Perfect. Y-intercepts, we plug in 0 into the x's. So we would get 0, 1 when you do the math there. Vertex form is y equals, I'll write our formula here, y equals a times x minus h squared plus k. So our a is 4 times x minus h, so x minus -1/4 would turn to plus 1/4 squared plus 3/4. So you just plug in your h and your k from your vertex, and then a comes from your leading coefficient there. Lastly, let's do 10. What should we do for number 10? So we want to find the zeros, the end behavior, the multiplicity, action at the x-axis. So let's start by finding the zeros. What do we do to find the zeros? Set y equal to 0. So we're going to want to factor. What should we do first to factor here? Perfect. Take out our greatest common factor, so that'd be -3x cubed. We're left with x squared minus 9. To find the zeros, we want to set these equal to 0. So we have -3x cubed equals 0 and x squared minus 9 equals 0. You could factor x squared minus 9 more, but you don't have to. You could just set it equal to 0 here. For -3x cubed, I'd divide by -3. What's 0 divided by -3? 0. So I have x cubed equals 0. This means that I have 3 of them. I have x equals 0, x equals 0, and x equals 0. You only have to list it once for your zeros, but if you want to put it more than once, that's fine. That way you know your multiplicity. What do we have a multiplicity of at x equals 0? A multiplicity of 3. And when we have a multiplicity of 3, what's the action that it does at the x-axis? Crosses. Since it's an odd multiplicity, it's going to cross at the x-axis. Noah?
So would we put multiplicity of 1 or put odd multiplicity?
Multiplicity of 3, because we have 3 of them.
So wait, do you classify all of them as odd and you put like odd multiplicity? Because they all go through.
For multiplicity, give me the number. Odd multiplicity tells us that it's going to cross. But when it asks for the multiplicity, tell me how many of each you have. But if it was the same for each, you could just classify it as the same. For the next one, we've got x squared plus 9. X squared minus 9. So we got to add 9 to move it to the other side. So x squared equals 9. What do we do next? Square root it. This is where a lot of people forgot a little step on the quiz. What should we do next? Plus or minus. Anytime you take the square root of both sides, you need the plus or minus. So plus or minus the square root of 9 is 3. Now this makes sense because we have 3 zeros here. We've got x equals positive 3 and x equals negative 3. So that gives us our 5 zeros that we knew we were going to have at the start. So on my list, I'm going to say x equals 3 and negative 3. At these two numbers, we have a multiplicity of 1. When we have a multiplicity of 1, do we touch and turn or do we cross? We're going to cross. For number 8, what's the first thing we should do to solve? Awesome. We want to add the negative 7x squared to the other side. Let's put it in standard form. So we have 7x squared minus 6x plus 2 equals 0. You could try to factor. 7 times 2 would be 14. Do we have two factors of 14 that adds negative 6? Nope. Factoring does not work. What do we do when factoring doesn't work? Quadratic formula. So for our quadratic formula, 7 is going to be A, negative 6 is B, and C is 2. So negative 6 plus or minus the square root of B squared, so negative 6 squared, minus 4 times 7 times 2, 4 times A times C, over 2 times A, or 2 times 7. So just be careful when simplifying. Simplify one step at a time here. Negative 6 would be positive 6, plus or minus the square root of 36. 4 times 7 is 28, and 28 times 2, 56, so minus 56 over 14. So 6 plus or minus the square root of negative 20 over 14. Let's break down negative 20. What are two factors of 20? 4 and 5. 5 would just be 5, and two factors of 4 are 2 and 2. So what does the square root of negative 20 simplify to? Perfect. So 2i square root 5. So don't forget, take the negative out, turn it into an I. Then we had a pair of 2's that would come out also. So 2i square root 5. Can we simplify this anymore? Are all three of the whole numbers divisible by the same thing? Yeah, we could divide them all by 2. So we would get 3 plus or minus I square root 5 over 7. Just remember, I's are fine to get when you're solving. You can get I's, just not for your x-intercept. If you have an imaginary x-intercept, then you don't cross the x-axis. But other than that, when it says to solve, find the zeros, I's are okay. So let's say we have the square root of negative 4 times 5 plus the square root of negative 16. What should we do first here? You could distribute the square root negative 4. But what else could we do? Let's simplify it first. Let's get rid of those square roots and let's simplify. So the square root of negative 4 would be, Jackson said 2i, perfect. And then what's the square root of negative 16? 4i, awesome. So simplify it first. You don't want to multiply the square root of negative 4 times the square root of negative 16 and then have to take out the i's and multiply them together. It's just going to make it messy. So simplify it first. What should we do next? Now let's distribute. So we get 10i plus 8i squared. Can we leave our answer like this? No, what do we have to do next? Change the I squared to negative 1. So this ends up being negative 8. Could we say 10i minus 8? No, why not? It's not in standard form. We got to put the real part first. Negative 8 plus 10i. So that would be our answer.